All right, now that I have a better understanding of OSI, the hardware that's involved, I've got a kind of a question about the routing that happens, because you said something along the lines of, they make machines based on the IP address. Well, I can understand maybe I need to figure out where it goes, but how does it figure that out?
Oh, okay. So in networking, we have two addresses that we typically deal with. It's foundational, let's say. So there is the physical address of the device. So like your computer, or technically any device that goes on a network, the host nodes and the network nodes, they have what's called a media access control address, or MAC address.
Yeah, that's like the physical address on a card.
Yes. Think of it like the fingerprint of the device. They're unique. They're made up of a 48-bit identity. Typically, we see them expressed in hexadecimal. But what they're basically doing is they have a portion of them, 24 bits of that, is used for what we call an OUI, an Organizational Unique Identifier. And that is registered to, let's say, the organization has that from the organization is called IANA, right? So they hand out these, you register these OUIs, and they're tagged to you. Like, for example, Crestron, one of our big ones that we always saw in class was 00107F. So anytime you would look at an admin would look at a scan of the network and see those MAC addresses starting with 00107F, it was a Crestron component.
Yeah, which could be really powerful if I'm trying to manage a network and make rules based on the gear you plugged in.
Correct. Yeah, absolutely. Because the gear you plugged in, remember, only Crestron components will have that 00107F. So if you wanted to put down rule sets on how they communicate, where they communicate, VLAN locations, whatever, you could do it based on that very information. So a MAC address is incredibly, let's say, unique to the individual device. Part of that, like I said, part of it is the OUI. The second part is the vendor number. So think of it from a Crestron perspective. 00107F defines that for us, that it's our thing, and there's a little bit more to it than that. But the last 24 bits is kind of like the MAC serial number of the device, which is why they're unique. Now, the important thing to understand about MAC addresses is they are associated with layer 2 of the OSI. So back when we were talking about the switches, every port on a switch, when I plug a device into it, will now associate the MAC address of the device that I am to the interface on the switch. So I now know physically where you're plugged in.
Yeah, you say physically. You mean like the port number.
Yes. So like port 1 on a switch, whatever's connected to it, I see the MAC address, and there's a table in that, let's say, switch, the network node. And it will actually mark and register and keep track of those MAC addresses physically connected to each port.
Okay, so what about the IP address, though?
Okay, so the IP, now that MAC address is where we can talk locally. What happens, let's take our email example, that you and I are not in the same building, right? That means that you're in a network and I'm in a different network. That's where the IP address comes in. The IP address is the network prefix, or the network identity, along with a host identity of that individual device again. And it's used for layer 3 communication. If you and I are not in the same network and you need to leave your network, the IP address is the tracking mechanism by how we get from network to network, from source to destination. So an IP address, as we've seen them before, I'm sure you're familiar with seeing one, you see it as this, what we call dot decimal noted number. So something like 192.168.1. Pick a number, 155 example. These are all 8-bit values, which we call octets. And with an IP address, we get two specific things. We get an IP address and a subnet mask. And the subnet mask, or a bit mask as we call it, tells the computer network, if you will, which part of the IP address is the network prefix and which part of the IP address is the ID of the host.
Yeah, I've kind of noticed, I won't call it strange behavior, but interesting behavior. Like you're setting a static IP address and you start to type in the address, 192.168.1. Whatever.
Right.
And you hit tab or you go down to the subnet mask and it starts to fill it in for me.
Yeah. So what it's typically doing when you kind of type in specific IP address ranges, it knows based on, let's say, not old technology, but how the network addresses were defined. We had different classifications. So when you see like a 192.168, based on its identifier as a classed network, it would know that you were, let's say, a 255.255.255.0 network prefix or subnet mask. Mm-hmm. So that would then say, okay, in your network, which the network ID now working with the subnet mask says that your network ID was 192.168.1, and that your ID of the host would be .155 in that network.
Gotcha. So it's like a network address and my physical address.
Yes. Well, the physical address is still the MAC address, but the network address or the IP address is identifying the network you're in and your host identity in that network, and then it actually still uses the MAC address. So if we use all three of these things together, let me maybe draw a parallel here. Think of if I was going to send you a letter, like you did email, I'm going to send you a letter, and I'm going to equate this to the IP address and MAC address. So the IP address would be like the zip code that I would put on the envelope. It tells me which network you're in or which zip code area that you belong to. And then the host part of that IP address would be your house address. So wherever you happen to live in the city. And then finally, the MAC address would be you, Kyle. So I have you specifically, your house, and which city you're located in. And that's kind of what an IP address and a MAC address is doing.
Yeah, it sounds like it's kind of just, widening it out and then narrowing it down until it's me.
It's you. Yeah, it's absolutely true. Because we've got your different locations, we've got different areas. All we're trying to find out is where exactly are you, and we use the IP addressing scheme to get from network to network, and we use the MAC address to know physically where you're plugged in.
Okay, so machines don't look at the numbers, though, right? They just see ones and zeros.
Correct. And that's why the way the IP addresses and these devices report to us, it's so that we understand what they look like. So when we say 192, that's not what the computer sees. The computer sees a string of ones and zeros. In fact, we always say 192.168. We always throw the dot in there. There's no dots. It doesn't establish a dot. It's literally a string of ones and zeros.
Yeah, I think that's called chunking.
Yeah.
Just like we do with telephone numbers. We just don't rattle our number off because we wouldn't be able to remember it.
Correct. So you put these separators so that you can identify a range of... Now, again, based on the octet, that 8-bit value, we have a range of numbers we can represent. In other words, 0 to 255. So the other important thing to understand is how that subnet and IP address work together is that the subnet mask, which we actually kind of changed the way we have said about that. Like the subnet mask, we've been so used to saying 255.255.255, whatever. We have another way of doing that, which I'm sure you might have seen in some Crestron components.
Yeah, you see, I'm sure you're going to CIDR notation here.
Yeah.
Yeah, you can see it in some of our control systems.
Right. So a CIDR notation is exactly the same thing. It's still the bit mask, but what CIDR stands for is classless interdomain routing. And what the cause or what the purpose of CIDR notation was is to easily describe. Remember, we're doing this 8-bit values again. CIDR just tells us how many consecutive ones that I have in the bit mask.
That's exactly what I was about to ask you. Is because it's always slash and a number. That number represents
how many consecutive ones from left to right.
If I was looking at the binary number.
If you were looking at the binary number, right? So take all of those binary values that you'd have for each octet, right? So you've got 32. I could have 32 consecutive ones. I wouldn't, but I could have 32 consecutive ones. That slash is basically saying how many consecutive ones do you have? Now, it's important to understand here what it's defining is, as I mentioned before, how much of the IP address is for the network ID and how much of the IP address is for the host ID. And why this is important is if I had a /24 or a 255.255.255 network, it means that only the last octet is available to define the number of hosts I can have in the network.
So it would be 255, but that's not totally accurate because you lose some to broadcast and...
There's broadcast, which would be the 255 number. There's 0, which you don't use, and then typically we have 1 that we kind of, by let's say practice and repetition, we use 1 as what we call the default gateway. So what the default gateway, if you remember from talking about the hardware, the default gateway is the ID or the IP address of the device that I would say in my network, let's say, or for example, the email. If you were trying to send me an email, we're not in the same network. What you're doing is you're saying, all right, send this to Kevin via the IP and the MAC information from the OSI. It's going to identify, well, Kevin is not in this network. So the default gateway is now, okay, if I can't find Kevin here, go to the default gateway, and that's the IP address that will get me out of my local network. So to send an email across the country, the default gateway is like the front door of your house. How do I leave? I go through the default gateway.
Gotcha.
Now, that default gateway, and with those consecutive ones, we also have the ability to move it, right? So I don't have to be always a /24. I can be a 23, I can be a 25. But what it does impact is how many network IDs I can have or how many host IDs can have. So if I went from a 24 to, let's say, a 23, I effectively doubled the number of host IDs I can have in my network. So I would go from, let's just keep the number simple. If my last octet was reserved just for host IDs, I could have 255. But if I go, that's a 24. If I go to a 23, I've moved that bit mask to the left. I now can do 512. So I can have an option of how many computers do I need in a network or how many networks do I need. We call this subnetting.
Yeah, I think that's what like IT professionals use for management of areas too.
Absolutely. So as I mentioned just now, subnetting. If I were talking about, let's say, creating VLANs, I could make a control VLAN. I could make a, let's say, a building VLAN. I could net those differently. Like even from the 24 aspect, I could do a 192.168.1 for my, so call it computer side. I can do a 192.168.2 for my control side. And now I've given a separation of communication between those two networks.
Okay, this has been great.
Excellent.